Welcome to the deep dive. Today we're getting into something that might seem a bit strange at first
Oh,
glance.
yeah.
We're talking about 18th century philosophy and cutting-edge artificial intelligence. How are those connected?
It sounds like a stretch, I know, but the link is actually profound.
Right. So the big question we're tackling is, how do AI systems actually come to understand the world? Is it all learned, from scratch? Or is there something else going on, like a hidden blueprint maybe?
Exactly, a kind of innate structure.
Okay, let's unpack this. Imagine if your mind wasn't a blank slate, but came, like, preloaded with some essential software. That's basically what a philosopher, Immanuel Kant, proposed centuries ago.
And it's incredibly relevant to the AI we interact with every single day. It's quite amazing, really.
So what's our mission with this Dean Dies then?
Well, our mission is to explore Kant's idea. He called them a priori cognitive structures. Think of basic concepts like space, time, cause, and effect,
Hmm.
things we seem to just know. We'll look at how that idea shaped early AI, how it's still causing debates, and where things stand now. It really boils down to this tension, hard-coded rules versus learning everything from experience.
The nature versus nurture of AI, almost.
In a way, yes. We'll look at the pros and cons of each, and importantly, how they're starting to merge. It's fascinating how these old philosophical arguments map so perfectly onto modern AI challenges.
And we've got some great sources to guide us, folks like Vadinsky, Kakembo, Daskal, Sloman. So we'll walk you through it. It should give you a much clearer picture of how AI, well, thinks.
Let's hope so.
All right, let's start with Kant, this a priori idea. He argued that concepts like space-time causality, they aren't learned purely from what we see or hear.
Right. He said they're more like built-in mental categories, frameworks our mind has to have before it can even make sense of experience, prerequisites, essentially.
So not learned, but inherent,
Exactly. And this idea directly influenced early AI. Researchers thought, okay, maybe AI needs these shortcuts too.
like giving it a head start.
Precisely. They built systems with what they called schemata, or innate modules. It's the hard-coded side of the AI brain. Instead of figuring out everything, it had some basic wiring to organize incoming data.
And you said this isn't just theory, it's in actual AI we use.
Oh, absolutely. Think about computer vision. Many systems use pre-configured geometric concepts.
Like knowing about shapes and lines already.
Yeah, sort of a built-in understanding of space, very Kantian. It helps the AI interpret visual scenes, recognize objects, track movement, things like that.
Okay, I see. What about language?
Similar idea. Some language models start with predefined syntactic rules, a basic grammar structure. This structural prior helps them learn new languages or dialects faster. They combine that innate structure with the new sensory input, just like Kant suggested for humans.
So this is really under the hood of things like facial recognition or even self-driving cars perceiving the road.
It often is, yeah. That foundational structure is key in many systems, but it's not without its problems.
Okay, the downside.
Right. As Vadinsky points out, the worry is that these pre-configured frameworks can actually restrain the system, make it too rigid.
How so?
Well, real-world data is messy, complex, nuanced, rigid categories, these preset boxes. They can really struggle with that ambiguity. They might limit the AI's ability to generalize beyond its initial training.
Okay, so it's like having a really strong, specific tool, but it only works for one exact job. It lacks flexibility.
That's a good analogy. It struggles when things don't fit the predefined mold.
Can you give some examples of where this rigidity causes issues?
Sure, take knowledge graphs. They're great for organizing relational information in a hierarchy, very structured, very Kantian.
Right.
But because they're often static, they can miss the subtleties, the complexities and nuances when real-world relationships change or aren't so clear-cut.
Okay. What else?
Or think about robotics. Some robots use predefined kinematic models for movement. They know how their joints should move.
Makes sense.
But these systems often suffer from rigidity. They struggle to learn abstraction or transfer skills to new tasks. They might be great at the one thing they were programmed for, but fail at many general tasks.
Not very adaptable then.
Not really. And even older symbolic AI, the rule-based systems, they rely on these fixed representations that can introduce biases. And they struggle to adapt to dynamic contexts.
Like language.
Exactly. A system focused purely on syntax might miss the actual meaning if the context changes. Think about sarcasm or how word meanings shift slightly. A rigid system might completely misunderstand. English and Finnish are good examples where context is king.
So efficiency comes at the cost of flexibility. The structure helps generalize quickly, but it struggles with ambiguity or anything outside its predefined boxes.
You've got it. That's the core trade-off.
Which naturally leads you to wonder,
Right.
what's the alternative? If Kant's preloaded mind isn't the whole picture, what else is there?
Well, that brings us to the other end of the philosophical spectrum, empiricism. Thinkers like David Hume.
Ah, the blank slate idea.
Precisely. For empiricists, cognitive capacity is entirely learned from experience. No innate structures, no preloaded software. You start empty and build everything from sensory input.
And how does that translate into AI?
It leads to what some call radically empiricist systems, AI designed to learn only by experience with absolutely no built-in knowledge or pre-analysis of data.
Just raw observation and pattern finding.
Essentially, yes. Let the data speak entirely for itself.
Okay, but that sounds hard. Does it work well?
It has its own set of challenges. As Vadinsky notes, these systems can do well with simple data, but they often cannot cope when tasked with abstraction, generalization, or transfer.
Why not?
Think about connectionist models, the neural networks behind a lot of modern AI. They need enormous amounts of training data, huge amounts.
Right, we hear about that all the time.
And they can struggle to generalize beyond the specific patterns in that data. They need consistent features, basically all possible variations, to build the connections from the ground up. There are no shortcuts, no built-in structures to help them along.
So one side is too rigid, the other needs massive data and struggles with new situations. Seems like neither is perfect.
Exactly. And that's why the field has seen a shift recently, a more pragmatic approach.
What kind of shift?
Well, instead of being strictly Kantian or strictly empiricist, the models have, as Vadinsky puts it, come to coexist. People are building hybrid systems.
Mixing and matching. Best of both worlds.
That's the goal. Blending the approaches allows for adaptivity, the learning from experience part, but within a structured system. So you get flexibility without throwing out useful prior knowledge.
Okay, that sounds promising. Are there actual systems built like this?
Yes, definitely. A key example is the Clarion cognitive architecture. It uses what's called an explicit-implicit split.
Explicit-implicit, what does that mean?
The explicit part is rule-based, symbolic, like knowing the rules of grammar or logic. That's your Kantian structure.
Okay.
The implicit part is subsymbolic, connectionist. It learns patterns from experience, like developing intuition. That's your empiricist adaptivity.
So it has both the rule book and the intuition.
Exactly. This lets it handle both familiar situations using rules, well-known contexts, and adapt to new situations using learned patterns, novel contexts. Liobra is another architecture with a similar idea, using subsymbolic elements for continuous adaptation.
That makes a lot of sense. It's like having a planner and an improviser on the same team must make them incredibly versatile.
They are very versatile, but, and there's always a but,
Here it comes.
this blend introduces its own challenges. Specifically, those adaptive, subsymbolic, implicit parts. They can be really hard to understand.
Like a black box.
Pretty much. The subsymbolic representations are difficult for system architects to fully understand and predict. You see the input, you see the output, but the why in the middle can be incredibly murky.
So debugging that must be a nightmare.
It can be. And this raises a critical point Vadinsky makes. If the mechanisms are unknown, it may result in an inability for the architecture to be effectively utilized or even debugged.
That sounds like a serious problem, especially for critical systems.
It is. It's not just a technical headache. It touches on trust, reliability, control. That's why there's such a push for greater transparency in these systems. We need to understand how they're making decisions, especially the adaptive parts.
And that need for transparency, for understanding the why, connects directly to bigger issues, right? Like ethics and accountability.
Absolutely. How you design the AI more Kantian structure or more empiricist learning or the hybrid mix has direct consequences for whether you can make it accountable.
Are people demanding this? Lawmakers, regulators?
Yes, very much so. Look at the EU guidelines, for example, cited by Kakimbo. Both recent ones and upcoming ones emphasize things like transparency, explainability, accountability, and inclusiveness.
So AI can't just work anymore. It has to be understandable and fair.
That's the direction things are heading. Performance isn't enough. We need systems we can interrogate, understand, and hold responsible. Embedding these principles right into the AI's architecture is seen as a proactive way to build more trustworthy AI.
So, wrapping this all together, what does this mean for the future of AI and maybe for, how you listening interact with it day to day?
Well, it really highlights that philosophy isn't just an academic exercise here. Thinking about Kant, about Hume, helps designers grapple with the difference between innate structures and pure learning from experience.
It gives them a framework.
Exactly. Philosophical analysis helps define potentially universal characteristics needed for efficient understanding. It guides researchers, as Sloman argued, to focus on building the right kinds of context sensitivity, avoiding total rigidity, but also avoiding the chaos of learning everything from scratch. It helps tune the balance.
What a journey, huh? From Kant's preloaded mind through the empiricist blank slate and landing on these complex blended hybrid systems we have today.
It really is. We saw the structured, rule-based approach giving robustness but sometimes lacking flexibility. Then the purely learned approach offering adaptivity but demanding huge data and struggling to generalize.
And now this convergence, trying to get the best of both.
Right. But challenges remain. The meaning grounding problem that Daskell talked about, how does AI really connect symbols or words to actual meaning in the world? That's still a huge hurdle.
Yeah.
Semantic ambiguity, too.
So the AI might use a word correctly but not truly get it?
Often, yes. And that's driving interest in making AI systems more dynamic, able to revise their own understanding dynamic reconfiguration. The core philosophical question remains. How does AI handle a priori knowledge? What does it know before experience, and how does it change based on experience?
Okay, so here's a final thought for you to chew on. As AI keeps evolving, blending these innate structures, the Kantian part, with what it learns, the empiricist part, consider this. If we can't fully understand or predict or even debug the most adaptive, the most learned, subsymbolic parts of these powerful systems, how much actual autonomy are we comfortable giving them? Especially when regulations, ethics demand transparency and accountability we might not be able to guarantee. It's a really deep question, isn't it?
It absolutely is.
Thanks for joining us on this deep dive, exploring how these old philosophical ideas are really shaping the technology of tomorrow. Definitely something to keep thinking about.